Hi, I'm Alec and I use high-throughput robotics to investigate disease. Effective disease management is heavily dependent on having sound information to make the right calls. Having information on antimicrobial susceptibilities means that veterinarians can prescribe the drug most likely to treat the infection. Having information on some of the most commonly occurring bacterial strains means we can develop targeted vaccines to treat and stifle the spread of disease. The value of this information is dependent on how accurately it represents the situation playing out on the farm. The greatest challenge to disease investigation is the fact that we're relying on a very small sample size to make grand inferences, which means that they're less likely to represent what's actually going on the farm. The lack of available data has nothing to do with the availability of samples, but rather the resource-intensive nature of investigating pathogens. High per sample costs and slow turnaround times mean that studies are often limited to only 200 isolates per farm per year. My PhD is focused around overcoming these previous limitations by utilising high-throughput robotics to provide affordable analysis of large sample sizes. To date, we've developed protocols that are equivalent in accuracy to a human, but far superior in throughput, endurance and cost. These new robotic protocols allow us to investigate up to 1,000 samples in just over a week. Now we're utilising this technology and applying it to investigate diseases of significance to pig producers, namely the respiratory disease complex, which is of significant economic and production loss to pig producers. We've applied this technology to investigate a large sample of Pasteurella multocida, which is one of the bacterial pathogens most commonly identified in porcine respiratory disease complex. We've used the robotics to generate antimicrobial susceptibilities on this large subset of isolates and perform genomic investigation to look for common strains to vaccinate against. Following this study, we hope to apply this technology to current outbreaks, providing real-time analysis and guidance for vets and farm managers.